Josie, what strategy did you choose?
I'm not sure it's called, but the X and then the box.
Excellent. We call that generic rectangle diamond problem, but of course, in order to use it, you don't actually have to know those words at all. Why do we call it a diamond problem? Because if you remember, we originally started with that X looking like that. And then for those of you who did not study math here, here's the way the diamond problem works in general, is you got two numbers, X and Y, and you multiply them together and you put the result up here and you add them together and you put the result down there. And it basically, it's like a little puzzle game that you can play, but then it carried over to solving quadratics because it turns out that it was useful for this process. Cool. Josie, continue.
To the answer or the one?
Now let's continue with filling this out.
Okay, with the diamond 9x squared on the diamond.
Why?
I'm not sure.
Anyone want to jump in and fill in the blanks there? Why do we write 9x squared on top of the diamond?
You can see multiplied with two sides.
Okay, so let's make sure we put our hands up. But yeah, we fill in the squared and the constant right there. We multiply them, and we put that up there. Good, Josie, continue.
Then 6x on the bottom of the
Why?
because that's in the problem. I don't know.
Where?
After x squared.
Oh yeah. Our x term always goes on the bottom. This is always the x term. And this is the product of the squared term and the constant. So if you haven't seen this before, if you came from a different system, you may have your own way of doing this. Guys, to be honest, at this point, I don't care how you factor quadratics. There are lots and lots of different ways. I had a student come from another school and did this thing that to me looked insanely complicated. And I was like, I have no idea what you just did. But she did it every single time, and she got the right answer every single time. She had this beautifully factored quadratic. So I was like, okay, whatever you're doing, it's working. Knock yourself out. I love it. But this is the one that we do in our algebra classes here. So, all right, Josie, I keep interrupting and then come back to you. If you're not losing your train of thought, what comes next?
What adds 2 to 6 and multiplies to 9, 3x on the other side of the diamond?
Remember, x times x, xy, x plus y, x times y, xy, x plus y. So multiplies to 9, adds to 6. We've got 3 and 3, and of course we have to have x's in them. Cool. Josie, continue.
3x goes in the square and then on the side, the x3 and x3.
I would strongly recommend, let me back up for just a second. I agree with Josie, but let me back up for just a second. Sometimes people will start down here because they learn to start with a constant. The problem I have with that is that sometimes you end up with like negative x's up here. It's not wrong, but I find it a lot easier to start by just saying, well, x times x is x squared. And then, like Josie said, x times what is 3x, so that's got to be a plus 3. This has to be a plus 3. Let me show you what happens if you start the other way. Is you could theoretically say, well, negative 3 times negative 3 is 9. But then I need to have a negative here to make this true. And so then I get negative x minus 3 times negative x minus 3 as my factoring. It's not wrong. It's correct. It's just a lot more complicated. Because if you multiply these together, you still get all the same stuff. So this is why I like to start with the x squared term and figure out what goes here and here, and then use that to fill in the others. Also, I wouldn't write x3 and x3, because if you put a sign right here, +3 and +3, I feel like it makes it easier to then say, well, what plugs into my parentheses? Because I do get people get a little bit confused sometimes. They've got x3 and x3, so they're at x comma 3 and x comma 3 in their parentheses, which of course isn't factored, it's just numbers and letters. So even if you are getting it right, I would recommend putting that plus or a minus there, depending on what it is. So then, x squared plus 6x plus 9, Josie, is equal to
x3 plus x3.
what?
X plus 3.
All right. Hopefully this is familiar. We had some in the homework the other day. Guys, if you're not doing the homework, you're missing out on some of this refresh and remind from previous years. It's going to make it harder for you to pull this up when you need it. So if you're not doing the homework, remember the purpose of my homework is to give you a little bit of extra practice and to help you remember things from previous years that we're going to see in the future, that we're going to be using in the future. So I'd strongly recommend, if you're not doing the homework on a regular basis, this is why. This would be your second time seeing this if you had done all the homeworks, as opposed to your first time, and then makes it a little harder to remember. All right. Any questions about the process or the concept of factoring quadratics? Are we okay with the idea of what we're doing here? Any questions at all? Okay. Again, if you've got a different strategy at some point, I'm okay with that. And at some point I may call on you and you'll get to explain your strategy to the class. So, if you went to a different school that taught it differently, I think we will be interested to see how you do it and to hear your explanation. All right. Hi. How was your weekend? Good weekends? All right. Yeah, me too. I had a fuel injector code go on my car. A new set of fuel injectors is like $500. But the fuel injector code said it was injector number 6. So on Saturday, I pulled the intake off the top of my car motor, and I just pulled off the injector rail and I swapped 2 of the injectors and put it all back together again. It took me about 2 hours. And then I went for a drive, and then it threw another code and it said injector number 4. Aha! Bad injector, because if it had been wiring, it still would have said injector number 6. So I knew that I didn't need a new wiring harness, which would have been thousands of dollars, so that was nice. And then I went down to the auto parts store, and instead of buying 1 injector, because I don't believe in replacing 1 injector, they're all the same age. And instead of buying any injectors, I decided, you know what, I'm going to buy 2 cans of cleaner. Seafoam is what I use for strong cleaning like that. And I dumped them into the gas tank, and I put about 50 miles on the car, and after about the first 20 miles, the code went away. Yes. I saved myself $500 this weekend by knowing the littlest tiny bit about working on cars. So now I just have to decide, because I did take the intake off, and there's a gasket in there, and I didn't put a new gasket in. I'm debating maybe buying a gasket and this weekend taking it apart again and sticking a new gasket in, just so that I don't then get an air leak down the road. But yeah, I will say working on being able to work on your own vehicle. Usually I take the car, it's that red wagon out there, the Magnum. Usually I take it to a mechanic. And this time I decided to dive into it myself, and paid off, saved myself a lot of money. So I have a friend who bought his son an old Corvette when he turned 16, but he made sure it had a blown motor. And he said, here you go, bought you an old Corvette. If you want to drive, you're going to have to rebuild the motor. And I'll help you. And his son rebuilt the motor, and this is a few years ago. This is probably 20 years ago, but his son rebuilt the motor. I got it into beautiful working condition. And now he just feels like he can do anything he needs to do on his car because he started at age 16 with, if you want to have a car, you have to rebuild a motor first. So I'm a strong proponent of being able to do your own stuff. And even if you can't do your own stuff, knowing how. Because if you go to the mechanic and the mechanic says you need 6 new fuel injectors and that's going to be $600 because he's going to charge you $120 an hour labor rate. If you don't know anything except that the little blinking light came on in your car, you're going to pay $600 and you're going to get 6 new fuel injectors. Whereas if you know a little bit, maybe you think to yourself, you know what? I know enough about this to be able to go down to the auto parts store and buy 2 cans of cleaner and dump them into my gas tank and drive around for a bit before I go to the mechanic. So yeah, I'm a big proponent of knowing stuff. All right. You were working with graphing calculators on Friday. Got a little note saying that we had some struggles. Let's make sure we don't bring these into class because I don't want to accidentally get knocked over. Okay, so maybe you just set it over there off to the side for me. I grab it before you leave. Did everybody get one of these? Okay. Get it out. Get out your graphing calculator. Because this is a little explanation of how to do this stuff. Out. Okay, I'll load you in for today. Yes. You want to do a graphic calculator? So I am told that the library's run out of graphing calculators, but that they're looking into getting more. So, you have a graphing calculator? You can grab one off the side of my desk, if you would. Graphing calculator? Green sheet? Grab one off the side of my desk. There's a stack of them there. Please make sure you put them back on my desk at the end of class. Don't just leave them sitting on your desk. All right. Switch that. I want to pull up this. Push the on button. Well, you'll either get a blank screen or you get something that looks like this. Just depends what you want. Oops. Let's just play a little. Everybody push the y equals button. This is where your equation goes. Let's do x squared minus 3. So everybody type in x squared minus 3. So you know there's a shortcut button right here that will allow you to do the x, so you don't have to do alpha x every time. You can just push that button right there that says xt something something. I can't read it because it's fuzzy on my overhead. So x squared minus 3. X, and there's also, so power button is right here. It's called a caret. Or for squared, there's a shortcut button. For any other power other than squared, you could use the caret, but for squared, you can just come down here and push the squared button. Minus 3. Now, before we graph this, No calculator? No calculator? Using his? Grab one off my desk. There's a stack of them on the corner. I buy graphing calculators at swap meets and not swap meets, but garage sales. Sort of nice when you can spend 10 or 20 bucks on the edge of my desk, right there, behind you. Right there, next to the Latin book. There you go. When you spend 10 or 20 bucks on an old TI-83 graphing calculator and then have a stack of them to loan out to people in need, sort of nice. Guys, if I told you on a piece of paper without a graphing calculator to graph x squared minus 3, you'd probably start by making a table. Once you had made the table, you would need to draw a graph. And the first thing you'd be thinking to yourself is, well, how big do my axes need to be? Because here's my table. So we don't know in advance how big our axes are going to be. How far up and down do they need to go? How far left and right do they need to go? And that's going to sort of depend on a lot of things. And we're going to talk about that a little bit later. But a good place to start on the graphing calculator is just to go 10 by 10 by 10 by 10. Covers a lot of stuff. So here's how you do this. And it is on the green sheet as well. Maybe. Yes. Find the zoom button and press it. Everybody found a button that says zoom on it? Right there. Option number 6 is Z standard for zoom standard. Option number 6 will give you a 10 by 10 by 10 by 10 graph. You can either scroll down and hit enter, or you can just push number 6. There's a 10 by 10 by 10 by 10 graph with the equation y equals x squared minus 3 graph right on it. Now, everybody have this? Anybody not have that graph that looks like that? Anybody got anything weird on their screen? Fabian, what do you got on your screen?
Well, I do that, and then I go to zoom, I press 6, enter, and just wait.
All right, good. Error, invalid dim. Glad you got this, because this is an error that's going to show up on a regular basis. We need to know how to deal with it. Invalid dim. What this means is invalid dimensions. And you get an invalid dimension error if there is stuff in a scatter plot, but the stuff in the scatter plot is just like weird and wrong because you aren't making a scatter plot, but somebody was in the past, or you were in the past, or your buddy borrowed your calculator, or it was in your backpack and all the buttons were being randomly pushed as it bounced around your backpack because you didn't have the cover on. So how do we get rid of invalid dimensions? We have to turn off the scatter plots. When you get an error like this, there are going to be 2 choices. One is quit and 2 is go to. This one doesn't have a go to. Quit just means, okay, I get it. There's an error. I will quit and then I will go fix the error. Go to is a kind of error that if you select go to, it will take you right there and then you can fix it on the spot. If there's a go to option, choose the go to option because it saves you some steps. In this case, here's what I want everybody to do. I want you to find the stat plot high. What do we got? Oscar is not here today. Would you like me to take it? And you have a signature sheet? That's what we've done in the past.
Yeah, I'm gonna wait.
I'm fine with it.
Okay, all right. Cool.
All right. I want everyone to find the stat plot button. Hint, it's not a button, it's written above a button. What color is the writing?
Blue.
Blue. How do you get the things that are blue?
Second.
You push the second key, which is also blue by an amazing coincidence. Everybody push second stat plot. And you know what? I should give this back to Fabian so he can do his, and I will demo on mine. So hang on just a second. Let me get mine back up here. Second stat plot. Guys, this is where you make scatter plots. We will be doing this at some point. But if your calculator is trying to make a scatter plot, but it doesn't have any data, it will give you an invalid dimension issue or error. What you want to do is choose option number 4, which turns them all off. Once you choose option number 4, it will say to you, plots off. That's a question. Doesn't look like a question, but it's a question. You have to hit enter. Choose number 4, and then you have to hit enter. And when you hit enter, it says, aha, I have turned the plots off. I am now done. And now if you push graph, you will not get an invalid dimension error because you are not trying to make a scatter plot on top of your regular graph. Hexon, what happened to your calculator when you did plots off? What changed on your screen? Oh, push graph. Sorry, everybody push graph now. Find the graph button and push graph. Hexon had an actual scatter plot right on top of his parabola here. Oh, everything disappeared. That's weird. Huh. Okay, I have to show everybody how to fix this too. I don't know why that disappeared. Hexon had a scatter plot on top of his parabola. When we turned plots off, the scatter plot disappeared. But here's the problem, his graph also disappeared. I don't know why. But notice, everybody go to y equals, and notice how on yours the equals symbol is like highlighted, it's dark.
Yeah.
Hexon's doesn't have that, and here's what he had to do. You go to here and hit enter, and notice now his is highlighted. For some reason, it decided to unselect. The purpose of this is if you got a whole bunch of equations in here, but you only want to look at the graph of one, you can click on all the equal signs to unselect them and only graph the one that you want to graph. So it just makes it easier. You don't have to delete them all and then go back and type them all in again later. So now, Hexon has a graph of the parabola, but it doesn't have a string of little dots across it. Okay? Cool. Find the table button and push it. Hint, it also is not an actual button. Everybody find it? It's right above graph. Oh yeah, by a crazy coincidence, they put the graph and the table button together because those sort of go together, don't they? Thank you. Hey, look, there's the table for my equation. And I can scroll up and down and find the numbers that I want. Second, memory, reset, all, yes. Here, take the next squared minus 3 so we don't have to pick. Somebody was using your calculator for advanced stuff. All right. Now, remember I said that after you've made your, yes,
I got something else.
what'd you get?
What happened? X -2, Y 1. I don't know what happened.
Oh, that's okay. Just scroll up and down. Use the up-down arrows to go up and down in your table. So notice that the up and down arrows will take you, look at that, look at all those numbers. Woo! How far does it go?
Infinity.
will sometimes, well, probably not infinity, to the end of the memory register capacity on your calculator. It does have a finite memory. But yes, it goes up and down for quite a bit. All right, last thing, and then we're going to jump into the book and we're going to look at some of the questions in the book. You may want to make a graph that is not negative 10 to 10, negative 10 to 10. The way you choose how big your graph is going to be is by pushing the window button. Everybody push the window button. Find the button that says window. Have you noticed that all these main functions are just right across the top of the calculator, easily set there for you to push them? So when we push window, aha, the left side of my X scale, the right side of my X scale. X min, X max. Skipping down one, I'll tell you what that is in a minute. The bottom of my Y scale, the top of my Y scale, Y minimum, Y maximum. So you can now make your graph as big or as small as you want. You can make it taller, but leave it the same width. You can make it wider, but leave it the same height. You get to choose. You want it to go from 0 to 100 in the Y direction and from negative 5 to 20 in the X, you just type them in. Be careful. Everybody look down here. See the little minus in parentheses? You know how we always told you that subtract and minus were the same thing? Your calculator does not recognize subtract and negative as being the same thing. If you put -3 using the minus key and you meant to put -3, it will give you an error. X squared minus 3 uses this minus key. Negative 3x squared, you have to use the negative key. So yes, I know. Why? Weird mathematical reasons. Yes. Yeah, go ahead. Okay. X scale, Y scale. Guys, if you're going from 0 to 1,000 on an X graph, because you've got these big numbers, you've got numbers that are in the hundreds, you probably aren't going to put a tick every one on your X scale, are you? You might want to put a tick every X equals 100. So you put a tick at 100 and 200 and 300 when you're labeling your axis. That's what this does. If it says X scale 1, it's going to put a tick every one on your graph. You can change that to anything you want. Cool. We good with that? Does that make sense? If you go from 0 to 1,000, let me show you what that looks like if you've got a tick of 1. There's 1,000 ticks on that axis. Not very useful. Hard to read the graph. So when you go back there and you make it, well, I'm going to make it 100 because I want to have one that I can actually use to see my graph. 100, 200, 300, 400, 500, 600, so on. Okay. All right. Any questions about the basic uses of the calculator? As everything we just went over is right on here. You're sitting there doing some problem and you're like, oh man, I can't remember how to. Boom, there they are. Grab an Algebra 2 book, one per table, go. Yes. Why don't you jump up and work with Jasmine? Because I'm going to have Drew jump over and work with Hexon because I don't think Anastasia will be back because it's only 15 minutes. All right. I need an Algebra 2 book. Trade.
This is an awkward
Yes.
What?
As soon as Karen gets back, yes. Thank you. All right, everybody look at page 16, problem 1-27. I want you to put that equation in your graphing calculator. And then I want you to answer questions A, B, and C, including the question for part B, what window settings allow you to see the complete graph? You're going to have a discussion with your partner. What does that mean, the complete graph? How far do parabolas go? How far do they go? Infinity. They go forever. So how do you draw a complete graph of something that goes forever? I want you to have that discussion. What do we mean when we say draw the complete graph? Because obviously, we don't mean draw it to infinity. Class isn't long enough. We'd be here for a very long time. So what do you think it means when they say the complete graph? All right? Drew, jump over here, work with Exxon. So you got 3 questions. What does the graph look like? Describe it. What window settings to see the complete graph? In other words, what do they mean there? And we have a domain and a range. Go. And remember, look back through your notes when we're talking about description. What was that? What are those math words that we wrote in our notes? Yes. Because it wants a number there. So just go zoom and then choose standard and it'll just reset it. That way you don't have to try to figure out what to type in. It's always a good default. All right, remember you're writing stuff down, so you should have your notebooks out. If you don't write it down, you're less likely to remember it.
Number 27.
Don't forget on that description, go ahead and flip back through your notes. Look at those math words that we talked about in the description.
Put an equals in there.
So, did you put it in? Remember, first thing you gotta do is y equals.
What was the one that zeroed out? Oh, wait.
Do you have a green sheet? Okay, so remember, so go ahead and clear that. Remember, we don't put the equation in the main screen. Remember, we enter it by typing y equals. Now we can type in the actual equation right there. Put your parentheses right there. All right? No, that's not a description at all. If somebody said to me, hey, you've got Manny in your class, what does he look like? And I said, he looks like Manny. It's not helpful. So what does it look like? Go back to your notes, remember the math words that we talked about for descriptions? I don't know, you tell me, what's the definition, what definition did you guys come up with for complete graph? I mean, here's a question. Is that a complete graph? Why? Why not? Do you agree with that? Makes sense to me. Good. So let's see your graph. Oh, yeah, so if we both go to window, we can see that his. Do you need to go all the way to 100? Remember, it doesn't have to be the same in every direction, so you could diddle it and adjust it to get exactly what you wanted. Nonlinear. A nonlinear line? Really? You gonna say that? What words did we use at the beginning? Don't baby him. You already did that.
Yeah, so the floor.
Aha, nice and stuff highlighted. I love highlighting. Oh, you know what you can do? You can delete first one. Oh, you actually have to delete second. All right, and you need to type it into your calculator.
Forward, and forward under.
Does it? Oh, I see. You were talking about the other one. Gotcha. Gotcha, good. Describe. Good start. And then what else?
This,
You got
see the,
your calculator.
just showed it. What's the impact of,
I don't know, man.
Is it going up? Look, here, I got forever. Going up. Remember, we start way over there.
Find the bear.
Yeah.
And where we're going left, right. Is it increasing everywhere in there?
See the fucking dots. If you want to survive.
And then it goes up. So we're gonna have to split on description in 2 bits, aren't we? Because we got a different message here versus here. Cool. Really? Is it always? Right. Right.
Or just looking.
Am I always increasing? Where am I increasing? Well, up the increases.
With the right, yeah.
Where on the graph am I increasing? Which part of this graph is increasing? Which part is not increasing? You hush.
Your arm?
Both of them? This is increasing?
Yeah.
I want to go back and look at your definitions. How do we define? They're highlighted in there, we talked about it before. What do we define as an increasing function? U shape. No, it's not. No, because U's have a little tail over here. So it's totally not U shape. What's the word that we use? Go flip back. You might have been right before John got here. So you got some highlighted. Look, it's all highlighted. It's all highlighted. All right, guys, we will continue this discussion tomorrow. If you borrowed one of my calculators, put it on my desk. Books, back on the shelf. Homework keys, pass to the left. Left and forward. Anastasia should end up with a whole pile of homework keys in about 12 seconds. Go, go, go. Okay, thanks.
How was your weekend?
It was awesome. Especially the part where I saved myself $700. Homework keys up and to the left so they end up by Anastasia, and then I can just collect the whole pile all at once. All right, have a great day. Brian, can you grab that one and take it with you and stick it on the file as you go? Bye now. Thanks, Brian. Have a great day.
Like now I can't take it to college.
Thanks, that's for you. Oh, sorry, that goes right in there. The second straight down for second period. Oh, yeah, absolutely.
I didn't answer about all of them, but you did take some of them. I did the,
111, okay, the first one?
and 1.1.2b I did.
All right,
I did.
and I've got that one already. And then I got today's, yeah. Okay, awesome, thank you. Howdy.
Having a rough morning. Day two. Made day two today. Day two. That's what it is. Yeah, day two. My backpack. I bleached up my shirt. No.
We didn't do anything in biology.
Really?
Yeah. Well, we obviously did something, but nothing like that.
I bleached day two.
Yeah, we can do
It was really funny. Yes, I got a picture of it.
Yes.